Good evening. Welcome to SVN3E Environmental Science. Uh, Last class, we were talking about invasive species, and we had so many examples of different invasive species and how they affect different wildlife, including plants, animals. And then tonight, we're starting to get more into our work on environmental effects in humans. So, invasive species were the effect we were looking at last night. The night before, we were looking at oil spills and acid rain. And tonight, we're going to look at some of the pollutants that we have in the atmosphere and their effect. You can see we're starting in the booklet on page 8 of 19 of Unit 2. Unit 2, Environmental Effects in Humans, and tonight we're looking at common environmental effects. All right, let's get into it. Our Lesson 8 learning goal is that students will be able to identify and describe several air pollutants and their effect on humans. Okay, so there's another section in the textbook that we'll go over in a few minutes, but I'm going to start with just going into what the contaminants are. The textbook does such a nice job of giving definitions for a lot of terms. So I don't think we're going to need too many definitions, or they're given actually in the readings here. And then when we go to the textbook in a few minutes, we'll talk a little bit about what some of the terminology means. Okay, so we are looking at examples of inhaled contaminants. These are things that are airborne, and how they affect humans is what we're going to start with. So the first one on the list is asbestos. Asbestos is a mineral that was mined and then used for insulation. So it's been used in schools and homes and all sorts of places, especially before the 1990s. What was found in homes right up to the 1990s, and also in different various building materials until the 1980s. However, what they found out is that asbestos is very dangerous when inhaled. It can cause all sorts of lung diseases. If you do have asbestos, it's best that you get it removed from your home. If asbestos is sitting there, not being disturbed, it's okay. However, it's really dangerous when it's disturbed. So if you are wanting to get rid of it, you have an older home and you think it has asbestos, don't go in and start ripping it out. It's best to get contact professionals who can come in and remove it from the home for you. It's not dangerous just sitting there. It's dangerous when it's getting removed, like you're doing a reno, and you want to take it out, or if it's something it's in an old material, an old damaged, deteriorating material, you want to make sure that you are not coming in contact with it. Okay. Pathogens. Pathogens are just anything that can cause illness, like organisms such as viruses, bacteria, things that we call germs. Pathogens are germs. And you can breathe in a pathogen. You can also, touch something as well. But in this case, we're talking about the inhaled contaminants. So we'll stick to the ones that you're going to inhale. And we know from coronavirus that was an airborne pathogen. It means that you would breathe it in. You could also touch it, though, and then also get it into your system that way as well. So what happens is you inhale in this germ, this bacteria virus. It enters into your lungs, and then from the lungs it goes to your bloodstream. Examples are, like I just said, coronavirus, the flu. The flu can be passed, right, by airborne. Tuberculosis was a disease years ago that was airborne, and people would cough, and that would transport the disease. Okay, so pathogens is another contaminant. Carbon monoxide. We've talked about carbon monoxide before. We've discussed how burning fossil fuels, industry, that it can produce carbon monoxide. It's odorless, colorless. You don't know it's there. So, for instance, my little trailer that I'm hopefully taking out camping in the next few days, it has a furnace. And when I run the furnace, it emits different, because I'm burning propane, which is a fossil fuel, and it has emissions. And I also have something called the carbon monoxide detector. It's just like a smoke alarm. It's an alarm in my little trailer, and if it detects carbon monoxide, it goes off. Because carbon monoxide is very, very dangerous. When you inhale it, it gets into the blood, and it then prevents the blood from transporting oxygen. And so cells that need the oxygen, we have a continuous, we'll talk more about this in a couple of lessons ahead, but what we want to know is that blood needs to be continuously circled with oxygen going to cells and carbon dioxide and other waste products coming out of cells. And so you need that to happen continuously, and carbon monoxide messes with that system. Another contaminant is dioxins. They're created when we burn things. So anything like any fuel, wood, or we're burning garbage, something like that, these dioxins are released into the air or the soil around where you're burning, and they can enter into plants. Then the consumers eat the plants. Maybe we eat the plants and animals that have dioxins in them, and then they build up in fatty tissue. A result of that could be something like cancer, some immune system disorders, and we'll get in, like I said, a little bit more into the biology of it, looking at some of the diseases, etc., in a little bit. There's also something called chlorination byproducts. So, the drinking water in a city or a town often has chlorine in it. It's used to kill pathogens, it's used to kill viruses, bacteria. However, the chlorine reacts with the organic matter in water. Remember, water can have organic matter. And when it does that, it can make some new chemical byproducts of that. And so there's now studies that show maybe drinking tap water for a long period of time in a town or city could cause some issues if there's chlorine byproducts with it. However, most water produced by a town or a city is tested quite a bit, and so they're usually, the levels should be monitored. Remember, we talked about testing and monitoring. Should be monitored. Also, you could use something like a Brita. You can buy at a store, and they have a charcoal filter in there, and you run your water through that, and that will get rid of any of the chlorine byproducts. Bisphenol A, BPA, is a chemical in some kinds of plastics. Plastic bottles are an example of how you could have BPA go from the plastic bottle into the water or the drink you're drinking. It can do all sorts of things. We have hormones in our body that regulate things. They regulate how much energy we have, how we burn energy. They can regulate growth when we're young, right? We have hormones. They help us to grow, develop. There are some research that's showing when BPA is in the water that you're taking in, there could be also some types of not only disrupting hormones, but some types of cancer could result from that. DEET, DEET, is in repellent in the spray that you put on you to keep off insects. And you have to be careful that you're not using too much too often. However, really, in this part of the world, I don't know how you get away with not using too much too often. It's DEET's used to prevent mosquito bites, but it's also used for ticks, which have become more of an issue than they ever used to be in this part of the world anyway. I remember them being, when we went go visit out in Saskatchewan, there would be ticks and they'd all be very concerned and making sure they didn't have any on them because, of course, they can lead to diseases themselves. Tick bites can lead to Lyme disease and other things. So it is important not to have ticks. However, if you're using a lot of DEET to prevent that, you could have also issues with that. It can cause damage, in particular, to the central nervous system. So anything you have like that can cause you to have seizures, or you could shaking, things like that. So if you need DEET, what they suggest you do is wear long sleeve clothes. So long sleeves and long pants, socks, running shoes. If you're, at risk of getting tick bites or getting mosquito bites. Luckily, in this part of the world, mosquito bites mostly just cause uncomfortableness. They cause a lot of swelling, maybe, or they can get infected if they get scratched or something gets into them. But mostly they're just very uncomfortable. So, however, tick bites can be very serious and can lead to a lot of diseases in this part of the world. If you're going to warmer climates, of course, they have malaria, they have dengue fever, Zika virus. There's all sorts of things that mosquitoes can cause in those parts of the world. And again, you really need to be careful you're not getting bit by mosquitoes because those are illnesses that mosquitoes transfer. Okay, lead is another airborne product. Or another product that can be ingested and absorbed into you. However, it's not airborne. Lead is through your skin. So, back many years ago, lead was used in makeup. And I think in particular white makeup that was used on the skin to get that pale white complexion. Think of Queen Elizabeth I, where she had the white skin. And then there's Egyptians for eye makeup. So that was lead that they were putting on their skin. And also in lipstick, there's another place that they used to use lead. It is against the law to add lead to any of those products nowadays. None of the makeup products are allowed to add lead, but sometimes lead is in a product naturally. So they take the mineral they're using to make the product, and then it turns out that it did have some naturally occurring lead. That's okay. That's not, it's just if you're adding it directly to the product that is illegal. Paint's another source of lead. Um, there's been examples in history of painters affected by lead. Um, and one of the most famous ones um, is Vincent van Gogh, Michelangelo. There's lots of examples in history. However, I don't know that it's ever been proven or what if anybody's ever gone and actually checked if they had lead poisoning from paint. Um, so what does lead do? It can be mixed in the paint to make it better paint, richer colors. Um, and then um, up till 1960, it was in paint that was sold. And then if that paint now is very old, which it would be now, and it's chipping off, you have to be very careful that it's not somewhere that a small child, for instance, could touch it or put it in their mouths, etc., um, so that it doesn't get absorbed into the skin. The next one listed is mercury. It's also absorbed through the skin and can lead to mercury poisoning. It can be toxic. If it's in a landfill, it can cause the soil and the water to become toxic, and anything trying to grow there, any will absorb the mercury and be affected, if not just die. Any animals that are eating those plants then are affected as well and taking in the mercury. Remember, we talked about the mill in Dryden that makes paper, and that at one time it produced mercury that went directly into the water supply and to a local community where the community members were eating fish that were toxic from mercury, and then they had all sorts of health issues from that. Okay, electromagnetic radiation. Okay, so we have lots of examples in that. So when light comes from the sun, it also produces other wavelengths of light. We're going to talk about that in the textbook in a few minutes here. Just know that some of the other forms of light that come, some other forms of energy coming from sunlight can cause health issues. Microwaves. Microwaves can cause health issues. Your microwave oven that you use in your house could cause health issues, but it's got a proper insulation so that the microwaves do not come out and affect people. They're contained in the microwave. That's why it's really important not to use old microwaves. If you have an older microwave and it's damaged in any way, you really should get rid of it and just go buy a new one. They're cheap, $50. Probably get yourself a new microwave. Not worth getting radiation sickness because of an older microwave producing radiation. The last one listed is noise pollution. So anybody that's lived near somewhere noisy gets this one. In Sulika, we have the trains. People living near the train tracks sometimes have a lot of noise from the trains themselves, the whistle blowing when they're crossing in here into town, the sound of the when they stop and all the cars hit each other. Anybody who's lived near a big airport that's noisy. Sometimes I've stayed at hotels where planes are taking off and landing all night, and it's really hard to get a good night's sleep. But there's all sorts of things from noise pollution. Uh, if you have earplugs, sometimes people like that. They wear their AirPods so they can listen to nice music or something instead of the noise. Living in cities, I think you tend to have more noise pollution. However, you could have a noisy dog, a neighbor that's producing noise, all of that anywhere you live. They basically noise pollution causes stress, causes you unable to sleep, and then the issue from that is all the side effects of not sleeping. However, if it's really severe noise pollution, you could also get hearing loss or tinnitus when you get the ringing sound in your ears. Okay, there's our key questions for lesson 8. So now we're going to go over and just give me 1 second here. I'm going to go over to the textbook and I want to go through some of that. There's some really good information in the textbook on some of these contaminants, and also there's some good information on some of the terminology. Okay, it says there on page 61, it's 3.1 in the textbook, we're lesson 8 in the course, that pollutants are also environmental contaminants, it says there. Substances that may harm humans or other living things when released into the environment. So we look at the fact that a lot of these contaminants are produced by humans, not maybe individuals, but by factories, etc., creating a product. But their effect now is what we're looking at on humans. We've looked a lot at the effect of contaminants in ecosystems and in air, water, and soil. So now we're looking just some of the environmental factors that are affected by pollution. Okay, in the book here on page 61, it says air pollutants and their effects on other environmental factors. So there's 5 major air pollutants that result from burning fossil fuels, driving, factories, etc. Pollutants that are dangerous to humans if they're are released into the atmosphere. So carbon monoxide, we just talked about, CO is carbon monoxide. There's sulfur dioxide, SO2. The nitrogen oxides, remember they could be NO, NO2, NO3. There's different nitrogen oxides. Particulate matter, we've talked about that before. Those are the particles in the air, and our example of that was smoke. And hydrocarbons, which is when you have carbon and hydrogen form a compound. And we've talked a little bit about that, like methane gas, CH4. Okay, if you look on page 61, there's a good figure, 3.1, and it's showing what what contributes to air pollution in Canada. What is the source of this air pollution? And you can see there's lots there. There's agriculture, 10%, that's most likely methane. Commercial and residential heating, that's burning fossil fuels to keep your house warm. Consumer and commercial products. And transportation's very big, 27%. But it is not as big as industry. Industry is 52%. 52% of air pollution in Canada comes from industry. And remember, we talked about the monitoring and testing procedure using the stacks, the smokestacks, and how we have monitors, probes that go in and test what's being produced. So we've talked about it. We've talked about how to monitor it, how to try to reduce those emissions. Let's see what actually happens now to us when these are emitted. So there's carbon dioxide again, CO at the bottom of page 61. And it's from when we burn fossil fuels. However, they're only partly burned. It's called incomplete combustion. There's not quite as much oxygen as there is when carbon dioxide. And there's not enough oxygen to let them burn fully. Cars, lawnmowers, anything that's producing heat, they can all produce carbon monoxide. They also produce carbon dioxide, but in this particular moment, we're talking about carbon monoxide. So anything like a fireplace, a heater, electric, or not electric, sorry, not electric, like oil heater, anything like that has to have good venting, and the vent has to go to outside so that you aren't harmed by the carbon monoxide. A barbecue, you cannot barbecue inside. You need to barbecue outside where there's lots of air so that you don't get poisoned. When you sit in a car, you have to be careful. There's lots of, you're not sitting in a garage, for instance, with the car running. You want to make sure there's lots of air, you're outside, or else you'll again get affected by the carbon monoxide. Okay, at the top of page 62, there's sulfur dioxide, SO2. It's from burning a fossil fuel that has sulfur in it. All organisms contain sulfur. So if you have a fuel like coal or oil, it comes, remember, from dead organisms that were crushed under intense heat and intense pressure for millions of years. That's what you're burning when you're burning fossil fuels. As a result, they were living organisms at one time, and so they had sulfur in them. So when you burn them now, they produce SO2. There's other ways you can get SO2. Volcanoes, for instance, or sometimes some natural geysers, that kind of thing. It smells like rotten eggs. That's usually sulfur and sulfur dioxide being released. And the thing with sulfur dioxide that's very different than carbon monoxide is, of course, that smell like rotten eggs. And so you would know that you're producing that chemical by the smell. If you have carbon dioxide or sulfur burning, it produces sulfur dioxide. And then if it can mix with moisture in the air, and it can produce H2SO4, which is part of acid rain. And we talked a lot the other night about acid rain and all of the effects it can have on ecosystems. Nitrogen oxides, remember there's NO, NO2, NO3. It's formed when oxygen reacts with nitrogen at high temperatures. Okay, so you're burning, remember, most of the room you're sitting in is filled with nitrogen. And so when you burn a fossil fuel, nitrogen oxides, NO, NO2, NO3, can be produced. And so you have to be careful again when you're burning something, when you have a gas stove, kerosene heaters, any of those types of things. You have to be careful because nitrogen oxide can be produced and then react with chemicals in the air, and it forms contaminants, in particular nitric acid. Okay, which is again can combine nitrogen oxide or nitrous oxide combines with water in the air, forms nitric acid, and that produces acid rain. It's another component of acid rain. The other one mentioned on page 62 is particulate matter. The figure 3.2 is really interesting because it's showing you how much particulate matter is measured at different monitoring stations in Canada. And you'll see there they are showing how much particulate matter is being measured, which where it has higher or lower concentrations. You can see across the map that most of the capitals of the provinces and territories have the larger numbers. In particular, if again, remember we talked last night about Windsor and Hamilton. Hamilton having a lot of industry, Windsor being across from Detroit, which also has a lot of industry. You'll see they have bigger amounts located there. But pretty much all the way across, probably where there's a lot of manufacturing, you're going to have particulate matter. Now, we also talked about how this summer we had smoke. Smoke is particulate matter. So when you have smoke in the air, that is particulate matter, and it can cause a lot of the same things as particulate matter from factories. Um, there's also indoor air pollution. So those basically we've talked about always have been outside air pollution, factories producing pollutants, smoke from forest fires, those types of things. However, there's also indoor air pollution. You could have issues with particulate matter coming from insulation in your building. Wood dust is a big one. I've been doing some renovations in my house, and I know concrete and plaster dust. When I'm working on the drywall, that can cause a lot of particulate matter. So you have to be very careful because you do not want to be breathing in that particular matter, or it can get into your lungs and cause a lot of issues. It's irritating to the skin as well, the eyes, and your breathing. So the best thing you can do with those is to wear a mask if you're doing any sorts of home renovations to stop from inhaling any of those. Also, you can have particulate matter mix with other things in the atmosphere. Sulfur dioxide combines with oxygen and water and can form sulfuric acid from particulate matter. It kind of forms a place where that reaction can occur. And then we have this really interesting picture there on page 63, figure 3.3, and it's showing an image at Toronto's CNE. I don't know if anybody's been to the CNE in Toronto, but there was in 1927 that statue called the Goddess of Winged Victory. Beautiful statue. However, if you look at the right, in 1987, it was starting to come apart from acid precipitation. So if that statue is made from something called limestone, limestone, remember, can react with acid rain. Remember, in our part of the world, the granite rock, the really hard volcanic rock as well, in the Canadian Shield where we live, does not react with acid rain, but that type of statue does, and it forms something called gypsum. And gypsum wears away the limestone, and you can see how that's completely destroyed. Apparently, they put up a plastic copy in 1987. There you go. Finally, we have hydrocarbons and photochemical smog. Hydrocarbons are where you take hydrogen and carbon, and they can create many different oils, gas, propane, fuel, and again, they were formed from millions of years ago. And so hydrocarbons are in the fossil fuels, and then when they burn, they can form all sorts of different pollutants. We've already talked about some of them. However, the hydrocarbons themselves can also get leak or can get into the air, and they can be very poisonous. So you don't want to be breathing in hydrocarbons. They can cause cancer and other things. The other one mentioned there on page 63, and it's showing a picture of Calgary and showing some smog. Remember we talked about how smog's formed from hydrocarbons combining with nitrous oxides? and it's creating ground level ozone, which we know ozone's healthy and good to have when it's high up in the atmosphere and protecting us from the sun's UV rays. However, it can form close ozone can form at ground level, and it's toxic. It can kill plants. It can cause damage when you inhale it into your lungs. It can burn your eyes. So yeah, there. The reason there's smog there is because of the mountains. The mountains stop the wind from being able to come in and blow the smog away. I mean, you're close to the most beautiful mountains in the world. The weather is affected by those mountains and producing beautiful, beautiful weather. But the downside is that it does end up getting smog and causing issues when it does. Ultraviolet radiation is another form of energy that helps to form the smog. So, the electromagnetic spectrum is shown there in figure 3.5 on page 64. And you can see there's a list of wavelengths showing the longer going to the left and the shorter wavelengths going to the right. And so they're talking about in the size of that wavelength. You can see it goes from being the size of a soccer field down to the size of a water molecule, which is very, 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 very tiny. The names are very common to us. There's radio waves, and then microwaves, radar, infrared, ultraviolet, X-rays, gamma rays. You'll see they're all listed there. We've heard a lot of these. The different rays depend on how long the wavelength is. So UV rays, for instance, come in. Remember, they're what the ozone layer in the atmosphere is supposed to be protecting us from, but they do get through, and they can cause your skin to be damaged. They can cause sunburns, and then that can lead to other issues. You can actually get your skin can become infected from it. And then you could also get skin cancer. That's what we were talking about the other night, about in areas where there is a hole over in the ozone layer and UV rays are coming right through. It also can form smog. UV rays can help to form smog. It says at the bottom of page 64, the Earth's ozone layer used to filter out 99% of UV rays. And that's good. That's what we want. However, with the hole in the ozone layer, we know that it is getting more and more, allowing more and more rays to pass in. And we, if you recall, I don't know if we talked about this, but the reason there's a hole in the ozone layer is from chlorofluorocarbons. Those are chemicals that used to be in things like refrigerators, air conditioners, aerosol cans. I think they've mostly been banned. I would hope so, now that we know that they are putting a hole in the ozone layer. And they're not used in most appliances now. Chlorofluorocarbons are also part of greenhouse gases, and as we know, this is what's leading to global warming, where our planet's heating up. You'll see at the top of page 65, carbon dioxide is 60% contribution to global warming. Most of it's coming from carbon dioxide from burning fossil fuels. Chlorofluorocarbons, 22%. We haven't even talked about them too much, but they contribute 22% to global warming. Methane, 12%, and that's coming from grazing cattle mostly. And then nitrous oxides are 6%. Heat is becoming an issue. Global warming is becoming an issue. The amount of extreme weather being produced because the planet's heating up has become a real issue. Hurricanes, other types of storms are becoming way more common than they ever used to be. And then on the other side of that, we're getting warm, like heat waves, more, I should say, not warm, hot weather, heat waves, and they're causing all sorts of issues, especially in the north, in the Arctic. They're causing glaciers to be melting. The length of the season that polar bears used to be able to rely on cold weather, ice, to be able to hunt is also getting reduced. So, yeah, it's causing a lot of issues. Check your understanding. Our first question for this lesson is on page 65 at the bottom. And so we're in lesson 8. It's worth 2 marks. It says, what are the 5 major air pollutants that result from human activities? And we just listed those, so you're all set. We talked about noise pollution, and we looked at what some of the causes are, and you can see that they're listed there. There's a vacuum cleaner, food blenders, lawnmowers, motorcycles when they go by without that muffler, jet engines taking off. Okay, so those are examples, and they can just cause either damage to the actual ear, or they can cause issues with mental health too. Soil and water pollution are another section we didn't really talk about in the booklet, but you'll see they're listed there. On page 66 is heavy metals. We've talked a little bit about that. Mercury, we talked about, but there's also cadmium, arsenic, chromium. We talked about lead and aluminum. And we talked about how we need these heavy metals, zinc, copper, etc., in tiny amounts in order to be healthy. And we get those naturally from grains and plants. However, and we also take them in vitamins, right? Sometimes we take vitamins, make sure we're getting our amount. However, when they are put into the soil through industry, like through factories and stuff, they can also they can cause them to become toxic, and they can also become air pollution if they're in particulate matter, right? The smoke coming out of the stack has those. So there's a lot of regulations around that, and so factories have to be very careful that the byproducts are being tested and that they're not causing any issues for health issues. There's workplace chemicals. They can be solid liquid gases also. Herbicides are something that you use to kill weeds. So if you're working outside and you're spraying herbicide to kill things, pesticides to make things grow, any of those types of things can be toxic. It's careful that you're using the right gloves, masks, all the protection you need so that you're not inhaling any of those. Pathogens are listed on page 67, and you'll see that they talk about bacteria. And with that, we're talking about bacteria, viruses, fungi. You can have pathogens that are fungi, and they can be transmitted to humans in lots of different ways. So when remember how we try to take and make more rich soil by putting some of the biological solids on top of the soil to make it richer? Sometimes pathogens can get into that soil and then from there into the water supply. There's a bacteria, it creates a disease called cholera, and it can be found in contaminated food and water that's contaminated maybe from sewage. And a lot of the developing world that does not have the clean drinking water that we're so lucky to have can get a lot of issues from that disease. And then we have airborne pathogens, which we already talked about. Um, Animals can have the illness and pass it to humans. And that's what happened with coronavirus. It was in a bat, and the bat passed the disease to a human, and then it went all over the world. There's all sorts of examples of that. Ticks, we've already talked about. There's another example of how a pathogen can get transported. The tick or the mosquito can bite a human or an animal and transfer the disease over. So there's another example. Okay, page 67 at the bottom has our question, check your understanding question. What are the 3 common contaminants in soil and water? So we've just gone over that in the previous few pages. So go have a look at that. If we go over now to, no, just a sec, I missed one of the, yeah, that's good. That's actually, I don't know that we talked. Yes, the 5 major pollutants were on page 65. We did talk about that. Those were 2 marks. And page 67, check your understandings, worth 1 mark. The 3 common contaminants in soil and water. All right, we're going to go over to page 69. Those are where the review questions are. Lesson 8 is probably the shortest lesson in terms of the number of questions. And we're just going to quickly go over those, and then that'll be it for tonight. So page 69 at the top, section 3.1 review questions. Question 4 says, where do the majority of sulfur emissions in Canada come from? So remember we talked about how sulfur is in certain substances, and when we burn those, so go and look up what those substances are if you've forgotten. Question 6 says, give 2 examples of why particulate matter is considered a pollutant. Okay, so go back and review what we said about what is considered a pollutant. Remember, we said that a pollutant is waste material from human activities that causes harm in an ecosystem. So is you have to ask yourself, is particulate matter a waste material? And does it cause harm in an ecosystem? Another way you could look at that is that pollutants are also environmental contaminants, which are substances that may harm humans or other living things when released into the environment. Okay, so pollutants and environmental contaminants are types of environmental factors. And so that's what we looked at tonight, the different environmental factors. So that question then says, give 2 examples, it's worth 2 marks, of why particulate matter is considered a pollutant. And we go right over to number 12. And it said, and we've gone through this many times, and I think you'll have no problem answering this without even having to go back and review. But it says, where in the atmosphere is ozone beneficial to humans? Which part of the atmosphere is it beneficial? And where is ozone harmful? So think of it in relation to the surface of the earth. Where would ozone be beneficial? And where would it be harmful? Also, that question is worth 2 marks. So make sure you give an example and an explanation of where it's beneficial, and an example and an explanation of where it's harmful. Okay, that is our introduction to common environmental factors. You'll see how a lot of what we covered tonight we've already covered in different units, and that's because they kind of build on each other, don't they? We're looking at how humans are affected by these contaminants. And so the next thing we're really going to concentrate on in our next lesson is going to be how those contaminants enter the body. So we've talked in general about them being airborne or dangerous because they're absorbing into our skin. We're going to go into a lot more detail. We'll do a little bit more of the biology of the course tomorrow or next time we meet. Thank you very much for listening, and that is it for tonight. Thank you for joining me.